So hello, this is the third part of the video series on solving triangles. So today we are going to look at trigonometric ratios of acute angles. So by acute angles, I mean angles less than 90 degrees. So what are the common trigonometric ratios we look at? So if we have a right angle triangle, so you need to know that this is only applicable to a right angle triangle. So let's look at this right angle triangle. So if I label this A, B, and C, so you know that the side facing angle A is small a, this is small b, and this is small c. So it doesn't matter how you label it, but so we just have to be consistent. So the common trigonometric ratios that we will apply will be sine, cosine, tangents, and the reciprocal of those trigonometric ratios. So depending on what you have, then you'd identify which trigonometric ratio to use. So what are the trigonometric ratios? Sine, cosine, and tangent. So which is approximated as sine, sin, cos, as a shorthand form of those, and tan. The reciprocal of each of these, the reciprocal of sine, as the inverse of sine, is cosecant. So what is cosec? So cosec, the reciprocal of that's 1 over sine, put it that way. And the reciprocal of cosine, 1 over cos, is called secant, or sec. And the reciprocal of tangent is cotangent, or cot. Okay? So we'll look at this using this triangle. So the common way to remember, or the popular way to remember the trigonometric ratio is SOHCAHTOA. SOHCAHTOA. So which means, depending on what you have, if you have the opposite and the hypotenuse, you use sine. If you have adjacent and hypotenuse, you use cosine. And if you have opposite and adjacent, you use tangent. So let's say in this triangle, we have, okay, before that, let's write, I have my angle here, theta, for example. So this C becomes the opposite in this triangle because that's the side that is facing the angle. And B is the hypotenuse, and A will be the adjacent in this case. So sine of the angle, sine theta, will be opposite, which is C, divided by the hypotenuse, which is B. Then cosine of the angle theta will be adjacent, which is A, divided by the hypotenuse B, and tan of the angle theta will be opposite C over adjacent A. So for the reciprocals, cosec theta, as I said, is equal to 1 over sine theta, and that will be equal to the inverse of this, which is B over C. And sec theta will be 1 over cos theta, which is the inverse of this, as B over A. And cot theta will be 1 over tan theta, and that will be A over C. Okay. So these are the equations you'll be using, formula you'll be using to calculate whether the angles or the sides, depending on the information you have. Okay, let's look at some examples. Example 1. Let's share this. In a right angle triangle, ABC, angle A is equal to 58 degrees, and AB is equal to 8. Find BC and AC. So how do we do this? So we can draw the triangle to simplify the problem. So we draw the triangle. So okay. Additional information here that angle B is 90 degrees. Angle B is 90 degrees. So the B is 90 is at B. So B then A, then angle A says here 58, for example, then C. Now we know AB to be 8. So we want to find BC and AC. Now, looking at this triangle, we know that we don't have the opposite, clearly, because the side that is facing the opposite is that is facing the angle is the opposite. But we have the adjacent. So we can use that to find, we can use this angle and the adjacent to find the opposite and to find the hypotenuse using the appropriate trigonometric ratio. So BC is the opposite in this case. So now I have adjacent, I have opposite. I'm looking for opposite rather. So I can use tan. So tan of the angle, 58 degrees. So tan of 58 degrees should be equal to opposite, which is BC, divided by adjacent 8. So we can cross multiply here. So BC will be equal to 8 multiplied by tan 58 degrees. So what is tan 58 degrees? I start my calculator. So that gives 1.6. So BC equals 8 times 1.6, and that will give you what? 12.8. So that's BC. Then AC, how do we find AC? Now I know BC. If I want to find AC, I can use, I don't have opposite. I don't have opposite. If I want, I can replace this here. So I just want to assume that I don't want to use this. Now, hypotenuse and adjacent. So what do I use? Hypotenuse, adjacent. That should be CAH. So I can use cosine of the angle. Cos 58 will be adjacent 8 divided by hypotenuse, AC. So if I cross multiply, then I have Go to the next page. AC multiplied by cos 58 equals 8. So I can divide both sides by cos 58. Cos 58. So that gives me 8 divided by what's cos 58. So cos 58 is 0.5299. So and that gives me it's approximately 15.1. So that's that. Let's look at another example. I hope that's clear enough. Example 2. Given the triangle below, that so 44 degrees, 15, this is B, C, A, then so this 7. So we have to find the value of theta. So what do we do? How do we find theta? Now, if you look at this, we cannot use this triangle. We cannot use triangle BCD because we have just one information, just this side here. We don't know the opposite to this angle. So we need to find a way to calculate the opposite to this angle here using the information we have in triangle ABC. So that's what we do first. In triangle ABC, so we consider ABC, we can find BC. So this is ABC. So 44 degrees, 15, and this is C, A, and B. So BC is what I need. So, and this is the angle. So CA is the opposite, BC will be adjacent, and 15 is hypotenuse. So because I'm looking for the adjacent and I have hypotenuse, so I'm going to use cosine. So cos 44 will be adjacent, which is what I'm looking for, divided by the hypotenuse 15. Right? Because opposite CA. Sorry, I don't need the opposite to calculate this angle. So the cross multiply, then BC will be equal to 15 times cos 44 degrees. So BC will be 15 multiplied by, so cos 44 degrees, they give us 0.7193. So we multiply that by 15, then you get 10.79. 10.79. So that is BC. So now I know BC. I can use that information to get angle theta. So can do that here. I'm going to go to the next page. Now, in triangle BCD, now I have this side. I have this side as 10.79. This is the angle. This is the right angle. Okay. So the hypotenuse, I don't know. Then I know the adjacent. So I don't know the hypotenuse. So I know the opposite adjacent, that's tan. So tan of the angle will be equal to opposite 10.79 divided by adjacent 7. Right? So tan theta will be 10.79 divided by 7, and that gives you 1.54. So theta will be tan inverse of 1.5414. So to press it as tan inverse in your calculator, you press shift tan of the answer. Shift tan 1.5414, and that gives you 57 degrees. Okay, so I hope that is clear enough. So we stop there and we'll continue in the next video. Thank you.